Hi, this is Professor V.K. Patil. I welcome you to my video classes on basic electronics. In my last class, we have discussed half adder circuit. Today we will see a full adder. The basic difference between half adder and full adder is that half adder, it does not consider the carry which is generated previously. It means that it has only two inputs A and B and two outputs sum and carry. Whereas the full adder, it considers the carry which is previously generated. Hence, the input to the full adder are three. The input variables are A, B and previous carry, which is nothing but CE. And the output for full adder are sum and carry, out, right? That is the carry which is outputted. Hence, the block diagram representation of this full adder is, we have, this is the block which is basically a full adder. Input to these blocks are A, B, these are input variables. Also it has the input Cin. Cin means what? It is the carry which is generated previously. Then it has the two outputs which are nothing but sum and carry. It has the two outputs which are sum and carry out. Now, as discussed earlier, again I need to first find out the expression for sum, expression for the Cout, and then I can implement it by using the gates. How to find out the expression for the sum and carry out? For that, first I need to write the truth table. What is truth table? Truth table is nothing but listing of all input combinations and corresponding outputs. Here we have the inputs which are A, B and Cin, right? And corresponding outputs I need to write, which is sum and Cout. Is it right? Now, as we have three inputs, so different input combinations are 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. So these are the 8 different input combinations. 1, 2, 3, 4, 5, 6, 7, 8. Corresponding outputs we need to evaluate now. What is sum? Sum is nothing but addition of A, B and Cin, if any. Now here A plus B is 0. Again 0 is added, we will get a sum 0. Here 0 plus 0 is 0, 0 plus 1 is 1 and Cout in both cases is 0. Here again 0 plus 1 is 1, 1 plus 0 is 1 and carry is 0. 0 plus 1 is 1, 1 plus 1 is 0 with carry. So here we get a 0 sum and carry out as 1. 1 plus 0 plus 0, you will get 1 with carry 0. 1 plus 0 plus 1, you will get 0 with carry 1. 1 plus 1 plus 0, you will get 0 with carry 1. Here 1 plus 1 is 0 with carry 1, right? That is 0 with carry 1. Again you need to add 1, hence we will get 1 with carry 1. That is what? 1 plus 1 plus 1 is 3 binary and 1 1 is a binary equivalent for a 3. Now this is what the truth table for a full adder. Now from this truth table you need to find out the expression for sum and expression for Cout. Let us first find out the expression for sum. How to find out the expression for sum? Sum, it can be identified by observing this column of sum in truth table. You need to identify where there are the logical when values in this column. Now we have first value 1 and the corresponding input is 0, 0, 1. 0, 0, 1 means what? I need to write this as A bar, B bar, Cin plus. Now this term we have considered. The next value is this one. What is the input combination for that? 0, 1, 0. Here I need to write it as A bar, then here it is the 1, I need to write it as B, then Cin bar. plus. Next value is this one 1. Here input combination is 1 0 0. Hence I can write this as A B bar C in bar. And the last value is 1 1 1. Here I need to write this as A B C. Now this is what the expression for sum. I need to simplify it, right? How do I can simplify this? If you observe carefully, this term number 1 and the last term, they have the common term C in. So let us take that C in commonly. If you consider the second and third term, so we have common C in bar. We will take it out. Hence I can write the simplified expression for sum is equal to A bar B bar plus AB, which is multiplied by C in, right? Plus, now here I can take the common C in bar and the values are A bar B plus AB bar into C in bar. Is it right? Now, what is this A bar B plus AB bar, which is nothing but XOR operation? Is it right? A bar B bar plus AB, which is nothing but XNOR operation. Is it right? And we know that the output of XOR is complemented value of XNOR value. Is it right? So therefore I can replace this as, if I replace this value as a X, I will get here X bar, because we know that output of a XOR gate is complemented value of XNOR gate. Is it right? So therefore I can write this as S is equal to X bar into C in plus X C in bar. Now again this is nothing but the XOR gate output, X complement C in plus X. Now replace the X by the value, so therefore I can write that. So this A bar B plus A complement B bar, so here X is nothing but A bar B plus B A bar, which is nothing but basically a XOR B. Now replace this in this expression, you will get sum, which is equal to A XOR B is XOR with C, hence is XOR with Cn. Hence I can say A XOR B XOR C in. This is nothing but the expression for the sum. We have identified the expression for the sum, which is nothing but the XOR of A with B, XOR of this result with C in. Now let us identify what is the expression for C out. To find the expression for C out, you need to observe this column. Identify the values where these are 1 and corresponding input. Now for this 1, so I can write C out is equal to, for this 1 input combination is, what is input combination? 0 1 1. 0 1 1 means what? A bar B C in bar. So 0 1 1 means what? A bar B C in. A bar B C, which is added with next input combination, for which result is 1. For this input combination is 1 0 1. 1 0 1 means what? A B bar C in plus next one. Here we have one value, right? Here we have one value, which is 1 1 0. For 1 1 0, you can write A B C in bar, and last one is 1 1 1. I can write this as A B C in. This is what the expression which is written by using the, which is written from the truth table. Now I need to simplify this. Let us take C in common between these first two. So therefore I can write C out is equal to, I can write this as A bar B plus A B bar multiplied by C in. Okay. Then in between these two I can take AB common. plus AB inside the bracket Cin plus Cin complement. We know that Cin plus Cin complement, that is A plus A complement is 1. I can replace this by 1. This is nothing but the XOR gate, hence I can write this C out as A XOR B, which is multiplied by Cin plus AB, and this is nothing but the expression for C out. Now let us implement these two by using the gates. See here, now we have the three inputs A, B, C. A, B, C, these are the three inputs A, B, C in. So sum is nothing but XOR of these all three. This is XOR gate. This is XOR. Here I will get a sum, which is the expression A XOR B XOR C. How do I can find out the C out? C out is nothing but AB, that is AND gate. Then A XOR B output, here we have another input is Cin. So Cin I need to connect here. So this Cin is ANDed with this. So this is what the Cin, and this both outputs are added, hence I need to use the OR gate. This is nothing but the representation of a full adder by using the gates. See here, A, B, these are the inputs. I will get output which is nothing but A XOR B. Again this input is XORed with Cin. I will get a sum which is nothing but A XOR B XOR Cin. Then for C out, so here we have a C out, so which is nothing but A XOR B is ANDed with Cin. A XOR B is ANDed with Cin. Here I will get this output. Then AB, here you will get output AB. So AB is added with this term, so I need to use the OR gate. This is nothing but C out. Now if you observe this particular circuit carefully, I can say that this one XOR gate with AND gate, it gives you a half adder. One more XOR gate with AND, it gives you a half adder too, and OR gate. In other words, I can say I can implement the full adder by using two half adders and one OR gate. How do I can implement C? So block diagram approach. So we have the half adder 1, this is half adder 1, where inputs are for this block, we have inputs A and B. Okay, output is this one. Is it right? So here we have output. So these are the two outputs here. Now this output again it is given as the input for half adder 2. This is half adder 2. Another input for half adder is Cin, and output I will get which is nothing but sum. Okay, and C out is basically nothing but addition of this part with this one. So here I need to take this, and you will get a C out here. This is nothing but the implementation of full adder by using two half adders. Right? Now we will note this output here. Now see it. Now input for half adder 1 is A and B. Output I will get here sum 1, and let us say C1. Sum 1 is nothing but A XOR B. C1 is nothing but AB. Compare the equation of half adder. Now here half adder 2 inputs are S1 and another input is C1. So hence it is nothing but S1 XOR with Cin, which is nothing but A XOR B XOR Cin. Now C out, which is nothing but how to represent. So this C1 is ANDed with C2, where C2 is nothing but, what is this C2? A dot B. So here we will get output which is equal to this C out. So this is nothing but the implementation of full adder by using 2 half adders. In this class we have discussed how to implement the full adder, how to implement full adder by using 2 half adders. In my next class we will see some other digital circuit. Till then, thank you.